Our solar system is a vast and mysterious place. It's filled with planets, moons, asteroids, and comets. We often focus on the prominent players, the planets like Mars or Saturn. However, it's the less celebrated objects, like Jupiter's moon Carme, that hold intriguing clues to the universe's grand design. Carme is a small irregular moon residing in the outer regions of Jupiter's vast gravitational domain. Jupiter, the largest planet in our solar system, reigns supreme in its neighborhood. Carme, like its companions in the Carme group, is locked in a retrograde orbit around Jupiter. This means it circles the giant planet in the opposite direction of Jupiter's rotation. It suggests that this small moon was not born alongside Jupiter, but was likely captured by the gas giant's powerful gravity long ago. The study of such captured moons offers valuable insights into the early solar system. Despite its diminutive size, Carme captivates astronomers and planetary scientists alike. Its dark reddish surface suggests a composition rich in carbon-based compounds. While Carme itself is not considered a prime candidate for hosting life, its study could shed light on the distribution of organic molecules in the early solar system. Understanding where these molecules originated and how they were transported is crucial to unraveling the mystery of life's origins. The year was 1938. Seth Barnes Nicholson, an American astronomer, was peering through the lens of the majestic 100-inch Hooker telescope at Mount Wilson Observatory in California. Nicholson was particularly interested in Jupiter, the king of our solar system. He had already discovered 3 of its moons, Pasiphae, Sinope, and Lysithea. Little did he know that fate had another discovery in store for him, one that would further cement his place in the annals of astronomy. Seth Barnes Nicholson was no stranger to the cosmos. Born in 1875, his fascination with the night sky began at an early age. This passion led him to study astronomy at Drake University, and later at the University of Chicago. Nicholson's expertise lay in astrophotography, a technique that was revolutionizing astronomy at the time. By capturing long-exposure images of the night sky, astronomers could detect objects far too faint to be seen with the naked eye. On that fateful night in July 1938, as Nicholson meticulously examined photographic plates of Jupiter's vicinity, a faint speck of light caught his attention. It was incredibly faint, a mere whisper against the backdrop of distant stars. Yet its movement, slow and deliberate against the background stars, betrayed its true nature. This was no star, but a new moon in orbit around Jupiter. The discovery sent ripples of excitement through the astronomical community. Nicholson, following the astronomical tradition of naming newly discovered moons after figures from Greek mythology, chose the name Carme. In Greek mythology, Carme was a Cretan princess and one of Zeus's many lovers. Zeus, the Greek equivalent of the Roman god Jupiter, was a fitting namesake for the planet this new moon called home. Carme, though small and distant, was now officially part of our celestial family portrait. Its discovery added to the growing tally of Jupiter's known moons. Carme, like many of Jupiter's outer moons, is a diminutive world. Its diameter, a mere 40 kilometers, makes it dwarfed by the gas giant it orbits. Yet, despite its small size, Carme plays a crucial role in our understanding of the Jovian system. Its irregular shape, resembling a potato more than a sphere, speaks volumes about its formation and history. These collisions have left their mark, not just on its shape, but also on its surface composition and its chaotic rotation. Even from a distance of millions of kilometers, Carme reveals some of its secrets through its color. Its surface, a dark reddish hue, hints at a composition rich in organic compounds. The presence of these organic compounds on Carme's surface raises intriguing questions about the Moon's formation and the distribution of these compounds in the early solar system. Did Carme form in the outer reaches of the solar system, where these compounds were more common, or did it acquire them through collisions with other objects? While no spacecraft has ever visited Carme up close, astronomers have been able to glean some information about its surface by observing how it reflects sunlight. These observations suggest a surface that is heavily cratered, a testament to its long and tumultuous history. Billions of years of impacts from asteroids, comets, and other space debris have pockmarked its surface, creating a landscape that is both ancient and dynamic. By studying the size, distribution, and age of these craters, scientists can piece together a timeline of the bombardment events that have shaped Carme and its neighboring moons. Carme, a tiny speck in the vastness of space, performs a celestial ballet around the mighty Jupiter. Its orbit, far from the familiar circular paths of planets, is a testament to the complex interplay of gravitational forces that govern our solar system. Carme is not alone in this cosmic performance. It is a member of a group of moons known as the Carme group, all sharing similar orbital characteristics. These moons, including Carme, are much farther away from Jupiter than the famous Galilean moons, Io, Europa, Ganymede, and Callisto. Jupiter, with its immense gravitational pull, dictates the rhythm of Carme's celestial waltz. Carme's orbit, far from being a perfect circle, is significantly elongated, resembling an oval more than anything else. This elliptical path takes Carme on a cosmic roller coaster ride, swinging close to Jupiter at its nearest point and then hurtling back out to the distant reaches of its orbit. At its closest approach, Carme feels the full force of Jupiter's gravitational embrace, a force so strong that it creates tidal forces that stretch and squeeze the tiny moon. Carme's dance around Jupiter is made even more intriguing by its retrograde motion. Unlike most moons in our solar system, which orbit their parent planets in the same direction as the planet's rotation, Carme moves in the opposite direction. This retrograde orbit is a key piece of evidence that suggests Carme was not born from the same swirling cloud of gas and dust that formed Jupiter. Captured by the giant planet's immense gravity, Carme was forced into its current retrograde orbit, a celestial souvenir of a cosmic capture that occurred billions of years ago. Carme's fate is inextricably linked to the giant it orbits. Over billions of years, the gravitational interactions between Jupiter, Carme, and the other moons in the Carme group have sculpted their orbits, creating a delicate balance of forces that keeps them in their current configuration. However, this balance is not static. The slow but relentless dance of gravity continues to subtly alter their paths, a celestial choreography that unfolds over timescales far beyond human comprehension. Whether Carme will remain bound to Jupiter forever or eventually be flung back out into the depths of space remains an open question. Carme, despite its diminutive size and distant orbit, holds a significant place in our understanding of the Jovian system. Like a tiny weathered monument from a bygone era, it carries the scars and whispers of events that transpired billions of years ago. By studying Carme's physical properties, its unusual orbit, and its relationship to other members of the Carme group, scientists can piece together a more comprehensive picture of Jupiter's evolution. Unlike the Galilean moons, which are thought to have coalesced from a disk of gas and dust that surrounded Jupiter in its infancy, Carme's retrograde orbit strongly suggests a different origin. This orbital peculiarity points to a capture scenario, where Carme, and likely other members of its group, were once independent celestial wanderers, snared by Jupiter's powerful gravity. Carme is not alone in its distant dance around Jupiter. It is a prominent member of a family of moons known as the Carme group, all sharing similar orbital characteristics, including their retrograde motion, high inclinations, and significant distances from Jupiter. This shared familial resemblance suggests a common origin story, a cosmic drama that played out billions of years ago. The prevailing theory among astronomers is that the Carme group, along with other groups of irregular moons around Jupiter, were once part of larger parent bodies, perhaps asteroids or comets. Jupiter's immense gravitational forces would have ripped these objects apart in a catastrophic collisional cascade, scattering fragments into a chaotic dance around the planet. The study of Carme and the Carme group provides valuable insights into the chaotic early history of our solar system, a period known as the Late Heavy Bombardment. During this era, billions of years ago, the inner solar system was a cosmic shooting gallery, with asteroids and comets raining down on planets and moons. While Earth and the other inner planets have largely healed from these ancient scars, the surfaces of airless moons like Carme preserve a more pristine record of these ancient impacts. By analyzing the size, distribution, and age of craters on Carme and other irregular moons, scientists can gain a better understanding of the intensity and duration of the late heavy bombardment. Carme and its fellow irregular moons, though often overlooked in favor of their larger and more prominent counterparts, serve as valuable sentinels of the outer Jovian system. Their distant orbits and unique perspectives offer a different vantage point from which to observe Jupiter, its atmosphere, and its magnetic environment. Studying these moons and their interactions with Jupiter's magnetosphere can provide insights into the complex interplay of forces at play in this distant region of our solar system. Furthermore, the composition of these moons, particularly the presence of organic compounds on Carme's surface, raises intriguing questions about the distribution and evolution of these building blocks of life in the early solar system. In the grand tapestry of the cosmos, Carme and its fellow travelers in the Carme group may seem like insignificant specks, yet they hold a wealth of information about the formation and evolution of our solar system. While much of what we know about Carme comes from telescopic observations from Earth, the data gleaned, though limited, paints a fascinating picture of this distant moon. Its low density, inferred from its estimated mass and size, suggests a porous composition, perhaps a loose agglomeration of rock and ice held together by its own weak gravity. This porous nature, a common characteristic of many smaller bodies in the outer solar system, hints at a formation process where collisions and accretion played a more significant role than gravitational compression. Another intriguing aspect of Carme is its rapid rotation. While our moon takes about 27 days to complete one rotation, synchronized with its orbit around Earth, Carme spins on its axis much faster, completing a full rotation in just over 10 hours. This rapid spin, combined with its irregular shape, results in constantly shifting views of the Jovian system from Carme's surface. A hypothetical observer on Carme would witness a dizzying celestial display, with Jupiter looming large in the sky, its swirling clouds and great red spot a constant presence. Section 2. A Celestial Time Capsule. Carme's distant orbit and relatively pristine surface make it a valuable time capsule, preserving clues about the conditions that existed in the early solar system. Its composition, particularly the presence of organic compounds, offers insights into the distribution of these building blocks of life in the early solar system. These compounds, while not direct evidence of life on Carme itself, raise intriguing questions about the potential for life to arise in other, more hospitable environments around Jupiter and beyond. Furthermore, the study of Carme's cratered surface, a record of billions of years of impacts, can help astronomers refine models of the late heavy bombardment, a period of intense asteroid and cometary activity that shaped the early solar system. By comparing the crater density and size distribution on Carme to other airless bodies, scientists can gain a better understanding of the dynamics of this chaotic era and its influence on the evolution of planets and moons. Section 3. A Universe of Mysteries. Carme, though a relatively minor player in the grand cosmic drama, reminds us of the vastness of the universe and the endless mysteries it holds. Every celestial body, from the largest star to the smallest moon, has a story to tell, a unique narrative woven into the fabric of space and time. As we continue to explore our cosmic neighborhood, we are constantly reminded that our understanding of the universe is but a tiny flicker in the darkness. Carme, with its irregular shape, its distant dance around Jupiter, and its composition hinting at the building blocks of life, is a testament to the diversity and wonder of the cosmos. Its study, though challenging due to its distance and faintness, is a worthwhile endeavor, offering valuable insights into the formation and evolution of our solar system, and the processes that may have led to the emergence of life on our own planet. As we develop new and more powerful telescopes both on Earth and in space, we can look forward to unraveling more of Carme's secrets, shedding light on this enigmatic moon and its place in the grand cosmic tapestry. Each new discovery, no matter how small, brings us one step closer to understanding our place in the universe and the intricate web of connections that binds us to the cosmos. Section 1. Carme's Tale. A glimpse into the Cosmic Ballet. Carme's story is a whisper from the depths of our cosmic neighborhood, a testament to the enduring power of gravity and the intricate dance of celestial objects. This tiny moon, a mere speck against the backdrop of Jupiter's majesty, carries within its irregular form and distant orbit a wealth of information about the early solar system, a time of cosmic collisions and planetary upheaval. Its capture by Jupiter's gravitational pull, evidenced by its retrograde orbit, speaks to the chaotic nature of planetary system formation, a process where chance encounters and gravitational tugs of war shaped the celestial landscape we observe today. The reddish hue of Carme's surface, hinting at the presence of organic compounds, adds another layer of intrigue to its story. While not a direct indication of life on this distant moon, the presence of these building blocks of life in the outer reaches of our solar system raises profound questions about the distribution of these compounds during the solar system's formation and the potential for life to arise in other, perhaps more hospitable, environments around Jupiter and beyond. Carme, in its own subtle way, reminds us that the ingredients for life may be more common in the cosmos than we once thought. Section 2. The Unending Quest, Our Place Among the Stars. The exploration of celestial objects like Carme is not merely an academic pursuit, a quest to fill textbooks with facts and figures. It is a journey of self-discovery, a way for us to understand our place in the grand scheme of the universe. By studying the formation and evolution of planets, moons, and stars, we gain a deeper appreciation for the forces that shaped our own planet and the delicate balance of conditions that allowed life to flourish on Earth. Carme, in its own small way, contributes to this grand narrative, offering a unique perspective on the history of our cosmic neighborhood. As we continue to develop more sophisticated tools for observing the cosmos, telescopes that can peer deeper into space and unravel the secrets held within the light from distant objects, we can look forward to learning more about Carme and its fellow travelers in the Jovian system. Each new discovery, each piece of data gathered, brings us one step closer to understanding the intricate workings of the universe and our place within it. The study of Carme, though seemingly focused on a single small moon in a distant corner of our solar system, has implications that extend far beyond the realm of astronomy. It speaks to our innate curiosity, our desire to explore the unknown, and our drive to understand the fundamental laws that govern the cosmos. As we continue to explore, we must remember that every object in the universe, no matter how small or distant, has a story to tell. A story that can teach us about ourselves, our origins, and our place in the grand tapestry of the cosmos. Carme's tale is just one of countless stories waiting to be told. Stories that have the power to inspire, to challenge our assumptions, and to remind us of the boundless wonders that lie beyond our world.